This question is asked in gate 23 of instrumentation. This is from measurement subjects and from breeze concept. The question is, when the breeze given below is balanced, the current through resistor RA is dash milliampere. So this is what RA, we are supposed to find the current in this branch. You see students, so this current is given to us 3 milliamperes, and here one important fact is breeze is balanced. What is the meaning of it? Breeze is balanced means the galvanometer is reading 0. So what we can do is we can remove this galvanometer, we can replace the galvanometer by open circuits. We can replace it by open circuits. So now if I replace it by open circuit, my job is now very simple. So how does this circuit will look like? My circuit will be looking something like this. This is a resistor. Then this is another resistor, then this is what you galvanometer, this is open circuits, and fine. Then you have this, you have this, you have this, and then you have this, and this is connected to a voltage source. This is grounded. Similarly, it is like this. This is also connected to ground. So this is okay. All these values are same, right? R 10 milliohm, 10 milliohm, 10 milliohm, and this current is 3 milliampere. So if the bridge is balanced, this is open circuited. So this is how the circuit is now. So now this is a very simple network, students. So 3 milliampere is approaching to this node, and definitely there are two paths. So the current will divide. One path is this way, other path is this way. So we need the current in this branch. So I need this current. So if I call this is I1, so I1 is equals to net current 3 milliampere into its opposite branch resistance is R. I mean there are two branches. One is this branch RR2R and one is this branch. Opposite branch resistance divided by total resistance. Right? So now you see RR cancel out. So 3 milliampere by 3. So this happens to be 1 milliampere. So the current is basically 1 milliampere. So 1 is the right answer for this problem. Once the idea strikes to your mind that galvanometer has to replace the open circuits, this is not even 5-second job. So answer is 1 for this. Very simple and straightforward problem. This question is asked in gate 23 of instrumentation. This is from measurement subjects and from power measurement topic. The question is the full scale range of the wattmeter shown in this circuit is 100 watts. The turn ratio of individual transformer are indicated in the figure. The RMS value of AC voltage source is 200 volts. The wattmeter reading will be dash watt. So this is what the wattmeter, we are supposed to find its corresponding reading. So you know students, the wattmeter reading is given by voltage of pressure coil into current of current coil into cos of, okay, theta VPC, I mean phase of the pressure coil voltage minus phase of the current coil current. So this is what the wattmeter reading is. Okay. So potential coil is connected something like this. But here one fact that you need to notice is, so current through the current coil means this current we are expecting. So you see students, so the current coil is connected between two individual closed circuits. This is a closed circuit, this is another closed circuits, and the current coil is connected between these two circuits. So will there be any current through this? There won't be any current through this, because a current to flow you need a closed path as well as written path. Right? So if you imagine that the current is going this way, let's say some current is going this way, how this current will come back? The circuit is not complete. Okay, if we are connecting a branch between two completely closed circuit, the current in that branch is definitely 0 only. You don't have any current in this branch. If this could have been somewhere here, yeah, there is a possibility. But in this configuration, definitely this current is 0 because there is no written path for the current. So this current coil reading is 0, and 0 into something is always 0. So wattmeter reading is 0 watt. The circuit is looking complicated, you may skip it, but if you use this little bit common sense, the current coil reading is 0, so answer is simply 0 only. Right? So very simple common sense based question, answer is 0. This question is asked in gate 23 of instrumentation. This is from measurement subjects and from error analysis topic, we can say. Basically statistical analysis of error topic. The question is 5 measurements are made using a weighing machine and the readings are 80 kg, 79 kg, 81 kg, 79 kg and 81 kg. The sample of standard deviation of the measurement in kg how much? So this is, we are supposed to find the standard deviation. This question you can even answer using the class 10 maths, right? You have to find the standard deviation from a set of sample data. So this is again a formula based problem, students. So first thing is we have to find the mean. So mean is given by sum of samples divided by number of samples, divided by number of samples. So if I add the sample 80 plus 79 plus 81 plus 79 plus 81 whole divided by 5. There are 5 samples, right? If you find it out, so this is mean is coming as 80 kg. So this is denoted by x bar. Then the standard deviation, students, standard deviation is given by the well-known formula summation x minus x bar whole square divided by n minus 1. Because the number of samples are less than 20, we are taking n minus 1. It could have been greater than 20, would have taken it is n. So we have to now solve this equation. That will give us the answer. So this is equals to square root of, this is n minus 1. N is nothing but the number of sample. So n minus 1 is 5 minus 1. So how do you write it? So like there are five samples, right? So first term here it will be x is 80 minus x bar is fixed 80 minus 80 square. Next sample is 79 minus x bar is again it is fixed, right? 80 square. Next sample is 81 minus 80 whole square, right? Next sample is 79. So 79 minus 80 square. And the last sample is again 81 minus 80 whole square. So this is what is the standard deviation. So if you see, so this is 0. If I simplify it, so how much I get? So this is 0 plus minus 1 whole square plus 1 square, again minus 1 whole square plus 1 square divided by 4. So if you see the numerator, so it is coming 4, denominator is also 4, square root of 1, the answer is 1. So the standard deviation answer is basically 1 for this. So very simple, and again a formula based problem, students. Answer is 1 for this. This question is asked in gate 23 of instrumentation. This is from measurement subjects and from RLC measurement topic. The question is, inductance of a coil is measured as 10 millihenry using an LCR meter when no other objects are present near the coil. The LCR meter uses sinusoidal excitation at 10 kHz. If a pure copper sheet is brought near the coil, the same LCR meter will read less than 10, 10, more than 10, less than 10 millihenry initially, then stabilizes more than 10 millihenry. So what is the answer of it? So this question, students, like it's a common sense based question actually. I mean, no bookish approach will help you. You should have some information. What is that information you expect or it is required is the copper sheet property. This copper sheet, this is basically a what? This is basically a diamagnetic material. So what is the property of diamagnetic material? I mean, this idea you should have, then only you can answer this problem in a skilled way, otherwise there will be problem. So the property of diamagnetic material is, so it reduces the magnetic field, right? Magnetic field reduces. If magnetic field reduces, the flux linkage of course reduces. Then the inductor is related by a relation L equals to N pi by I, right? So in other words, this inductor is proportional to the flux linkage. So naturally the corresponding inductance value also reduces. So if you are bringing, so you have an inductor like this, okay? So its value is now 10 millihenry, okay? Now there are some flux linkage of this, that's why you are getting 10 millihenry. Now what I am saying is, you are bringing a copper sheet nearby this. So when you are bringing the copper sheet nearby this, so because of this property of diamagnetic, it will reduce the flux linkage. If the flux linkage will be reduced, naturally by this relation inductance value also reduce. But if you are bringing any material which increases the flux linkage, then in that case it will be more than 10 millihenry. Because of the property of this copper sheet which reduces flux linkage, answer will be definitely less than 10 millihenry. Maybe if you take a ferromagnetic material, right? So in that case, definitely it would have been more than 10 millihenry. So this is what is the common sense you need actually, right? In case if you have some idea like copper sheet property like this, you can answer. Otherwise, you may not answer this problem, right? So logically, it is definitely less than 10 millihenry because of the copper sheet property. It reduces the magnetic flux. So answer is option A for this. This question is asked in gate 23 of instrumentation. This is from measurement subjects and from digital voltmeter related concept. The question is a 1.99 volt true RMS 3 half digit multimeter has an accuracy of plus or minus 0.1% of reading plus minus 2 digits. It is used to measure 100 ampere RMS current flowing through a line using 100 is to 5 ratio class 1 current transformer with a burden of 0.1 ohm plus or minus 0.5%. The worst case absolute error in multimeter output is dashboards. So, first thing student is the multimeter output. Okay, this is given by, of course, in any instrument, the true value you get plus or minus some error, right? True value plus or minus error. So you should have the common sense like the unit is volt. So multimeter is used to measure the voltage in this case. So here you see that it is used to measure a 100 ampere RMS. So this is what is the corresponding true value. This true value is to be measured. If this true value is measured, you will be getting the error. Okay. So I is given to me, which is 100. I mean I true. Similarly, the Z value is also given. So this one is Z true. So Z true, if I ask you, you have to take the 0.1. I mean, this part is the error in this. So you have to take this one. So this is your I true. So similarly, Z true is 0.1 ohm. Then what is V true? V true is I true into Z true. So this happens to be 100 into 0.1. So which is coming as 10 volts. So the true value that it will measure is 10 volts plus or minus error. We have to find the error. You see the error specification. Error specification is 0.1% of reading plus or minus 2 digits. So 0.1% of reading means 0.1% of these true values. So plus or minus 0.1% of reading this is equals to nothing but plus or minus 0.1 into 1 by 100 into of reading this 10 volts. If you simplify this, so this is coming as 0.01 volts. So plus or minus 0.1% of reading is nothing but 0.01 volts. Right? So 0.1% of the true value, that is basically, it is 0.01 volts. But here we have plus 2 digits, plus or minus 2 digits. Or it is basically, in the previous year question, if you see, instead of using the word digits, they used to use the word counts, plus or minus 2 counts. So if the meter is set in this setting, if two clocks are applied, okay, what is that count basically? That is what the point is. So if the range selected is this one, okay, so the resolution in this case is given by the full scale values 1999 divided by the scale. Okay, what is scale? You simply make this DP turned off and you add 1. So 1,999 plus 1, that is basically 2000. So that is basically 2000. So you get the resolution in this range is 1.999 divided by 2000 if you find it out. So this is coming as 0.00099995. You have to take because we are calculating error because first 3 digits are coming 000, you have to go for the next bits. This is the resolution, but we need 2 counts. So 2 count means if the 2 clocks are applied in one cycle, this much of increment, 2 cycle means twice of this. So this belongs to 2 into 0.00099995. If you evaluate this quantity, students, so this is coming as 0.00199. 00199. So if I ask you what is the multimeter output, it will be true value, which is 100 plus or minus error 0.1% of reading, which is 0.01, okay, plus this plus or minus two digits or 2 counts. You have to add this quantity, which is 0.00199. So this is 100 plus, if you simplify this, this is coming as 0.0119. Okay, this is what the multimeter output. This is the true value and this is the error. So we are supposed to find the absolute error in the multimeter output. So the error is 0.0119 volts, right? So this is what will be the answer, 0.011. So this is again based on the previous year model question, students, so not a new one. So answer is 0.0119.